similarity between radicals and fractions that I didn't talk about on Friday, but just hold off on those for a second. Let's pretend I have 50 over 100 as a fraction. If I told you to simplify that, and you guys notice that, 10 goes into both of those, right? So I'm going to divide both of those by 10, and then this is going to simplify to 5/10.
The shelter in place has been lifted again. We are all clear.
So I realized, they both had a divisor of 10, so I divided a 10 out and I got to 5/10. This is not okay, right? We all know that this is still not simplest form. We could still divide both of these by what? 5, and we know that that's 1/2. I actually ended up simplifying that down in 2 parts. But I should have and I could have gotten right from A to Z if I had just realized the biggest common factor was what? 50. So I could have just done that in one step if I had just divided a 50 out. So I found a common factor and reduced it. It just wasn't the biggest common factor, so it sort of took me 2 steps to do that. Yes? So to draw my connection between radicals, let's take the square root of 48, for example. I know that one of the perfect squares that goes into 48 is 4, right? So I would break this down into root 4 times root 12, which would become 2 root 12. But that's not okay either. Just like the 5/10 was not okay, that's not okay either, because 12 still has a perfect square that goes into it, right? What goes into 12? 4. So I would keep going and I would break 12 down into root 4 root 3, and then that would be 2 times 2 root 3, which would be 4 root 3, and now I'm done. And the reason that happened is because I broke it down into a perfect square and something else, but it wasn't the biggest perfect square. Just like on this one, I took out a common factor, but I didn't take out the biggest common factor, so I actually had to do it again. What would have been the biggest common factor, Eric? Or not the biggest common factor, the biggest perfect square that goes into 48. I took out 4. That wasn't the biggest one, though, so I ran into having to do it again. Name a perfect square bigger than 4. 8's not a perfect square. Do you know the square root of 8? A perfect square that goes into 48. Nine. We can check it. 9 is a perfect square. Does 9 go into 48 though? No. Try another one. That works. So 16 times 3. That would have been the biggest perfect square, and then that would have immediately have become the 4 root 3. So if you can only find a smaller perfect square, you can then just repeat the process if you need to, just like with simplifying fractions. Do you see that comparison? Any questions on that? Okay, but you're going to make your life easier if you can find the biggest perfect square right off the bat. Same thing with simplifying a fraction if you can find the biggest common factor. The other similarity is with adding and subtracting. I can only add and subtract fractions if they have what? Common denominator, exactly. I can only add and subtract fractions if they have a common denominator. Radicals have to have a common radical. So right now, as these stand, I cannot combine these because they're not like terms. I will actually say they're not like radicals. One's a radical 4x cubed, the other one's a radical 9x cubed. They're not the same, so I can't combine them right now. If I simplify them, and they happen to then turn into like radicals, then I'll be able to do something about it. So if you can't combine them right from the start, fine, just go ahead and simplify. What's the biggest perfect square that goes into 4? 4, so I'm just going to leave that root 4. What's the biggest perfect square that goes into x cubed? X squared. So I'll break down x cubed into x squared times x. So that's going to become a 2, and that's going to become an x. 3 times 2 is 6x root x. Again, this is like just taking it slowly. This is like 2 problems in one. I just simplified the first radical. Moving to the second. What's the biggest perfect square that goes into 9? 9, so I'm just going to leave that root 9. Biggest perfect square that goes into x cubed? X squared. So I'm going to make that root x squared root x. Square root of 9 is 3. So 6 times 3 is going to be minus 18. Square root of x squared is just x. And then we have a root x. So now, are they like radicals? Yes. 6x root x minus 18x root x. These radicals are like radicals, so they're combinable. What's 6x minus 18x? Negative 12x root x, this would be. Your coefficients can actually be combined, and then you have that many root x's. Any questions on that? In 10, we have no like radicals. Agreed? So we just have to treat this as 3 separate problems and hope that they, maybe only 2 of the 3, but hope that there is some combining that we can do at the end. So biggest perfect square that goes into 3? Nothing, right? So that's not going to be broken down. We'll just leave that root 3. It's going to be stuck under the radical. X cubed breaks down into x squared times x. And so the only thing we can really do with this one is bring an x out in front. So it'll be x root 3x. And we move to the next problem. Biggest perfect square that goes into 12. 4. So root 4, root 3. That's our joke of the day. And then x itself can't be broken down. So the only thing I'm really going to be able to do to that one is change that square root of 4 to a 2. So, and I'll do it at the same time. 4x times 2 is 8x. So that'll be 8x root 3x. And then on the last one, biggest perfect square that goes into 27. So root 9, root 3. By the way, that's supposed to be a little bit longer. That x is supposed to be underneath. And then root x I can't really do anything with. So the square root of 9 is going to turn into a 3. Times the negative 2x that's already there is going to be minus 6x. And then root 3x. So all 3 of them became like radicals. So how many root 3x's do we have at the end of this? 3x, right? 3x root 3x. So we've got 1x plus 8x puts us at 9x, minus 6x puts us at 3x, root 3x. Again, it's just a process. You have to take it slowly. You can't try to rush through these. It's not going to go well. Okay, flip to the back. Similar with adding, subtracting radicals, but now I have cubed roots here. So obviously they're not like radicals from the get-go. What's the biggest perfect cube that goes into 24? What'd you say, Chris? 4 is not a perfect cube. 4 is a perfect square. So 8 it is. Someone said 8. It is. 24 can get replaced by 8 times 3. So the cubed root of 8 is 2 times the 2 that's already there is going to make that 4 cubed root of 3. And then we jump to the 81, biggest perfect cube that goes into 81. Mine's perfect square. So you have your lists back here for now. Obviously, hopefully you become more familiar with these numbers. But which of these numbers goes into 81 evenly? 27 times what? How many times? 3. So 2 cubed root of 27, cubed root of 3, because 27 times 3 replaces 81. So the cubed root of 27 is 3, times the 2 that's already there is going to make that a 6. So minus 6 cubed root of 3. And then we've got 4 of these, minus 6 of these. 4 minus 6 is negative 2 of these cubed roots of 3. Okay? It's tedious. It's not fun. I don't think anyone likes these, but if you just take it slowly, term by term, you should be fine. All right. There's a property here that is going to be really critical throughout the year, and this won't be the only time we do it. There's another section where we'll do it even in more depth. But I don't know if you guys know this, but when you're asked to take the square root of something, if that's a 2, let's say, that's the same as raising it to the 1 over 2 power. So for example, if I wanted the square root of 81, rather than actually using the square root button, I actually can raise it to the 1/2 power, and it will still give me the square root of 81. The cubed root, you could raise to the 1/3 power. So like 27, for example, we all know that the cubed root of that is 3. And I do have a cubed root button, but if I didn't want to use it, there's the cubed root of 27. Raise it to the 1/3 power. Okay? Exponents and radicals are the same thing. It's just that a radical is the same thing as a fractional exponent. So the cubed root is the same as a fractional exponent. Okay? So there's the property right there. And then here's the thing. As far as rules are concerned, do we know about radical rules or exponent rules? Maybe you don't know. I'll tell you. You know all about exponent rules. You know the power to power rule. You know the common base rule. All of that good stuff. So anytime you have a mixture, and this is critical, I'll probably say this 1,000 times this year, a mixture of radicals in a problem and exponents in the problem, you want to turn everything into exponents so that you can follow your exponent rules. So this cubed root, I'm going to change into taking this whole fraction to the 1/3 power. And then on top of that innermost fraction being raised to the 1/3 power, the entire thing is raised to the 2nd power. So the first exponent rule I'm going to apply here is the power to power rule. And what does our exponent rule say? When you raise a power to another power, you should multiply. So I'm going to leave my fraction untouched, but the whole thing I'm going to raise to the 2/3 power. And then every element within this fraction has to be raised to the 2/3 power. So starting with negative 54. Watch me on my calculator. You don't have to do this. Negative 54 has to be raised to the 2/3 power. Oh. We're going to come back to that. Just leave it like this. most of the time I will tell you that'll be a whole number. So that's the first term. X to the 9th to the 2/3 power. This is another power to power rule, right? X to the 9th, if I took that as like an individual problem, X to the 9th to the 2/3 power, what's 9 times 2/3? How many thirds? How many thirds? 18 thirds. 9 times 2/3 is 18 thirds, and 18 divided by 3 is 6. So that just becomes x to the 6th over y to the 4th to the 2/3 power. If I kind of did that separately, y to the 4th to the 2/3 power. 4 times 2/3 is 8/3. And that is what it is. We can't really reduce that. So this is sort of an unfortunate one because that negative 54 to the 2/3 power was a crazy decimal. What we'll actually have to do on the negative 54 is we'll have to kind of go back and do it in two parts. Take the cubed root of it first. Negative 54 to the 1/3 power is the same as negative 54, the cubed root of it. And then once we're done with that, then we'll square it. We'll separate it. So what is the biggest perfect cube that goes into negative 54? We still have a minute, so stop freaking out. What is it? 27. I'd break that down into negative 27 times 2. So the cubed root of negative 27 is negative 3 cubed root of 2. And then I'm going to square that. So the negative 3 squared becomes 9. And the cubed root of root 2 times the cubed root of root 2, that squared is going to be the cubed root of 4. Because 2 squared is 4. So that was a little ugly. That would replace that. So your homework is just to finish the bottom part and check all your answers and clean up earlier stuff now that that's hopefully been made clear. I do have your quizzes ready, but I seem to keep not really having